Before we scale that, we're going to look at another factor that does in fact affect time compression, which is task interaction. Task interaction is simply a notion where one task will interact with another task, and that does increase task loading. And it obviously increases time compression too. So those two notions then have to be brought together before we scale them, all right? What is task interaction? In this case, we have a linear task, and there's no interaction, okay? Task A is completing his run, and he's passing the baton off to task B. There's no real interaction there except at the baton pass, but that's a linear process. Over here, we have what we call essential interaction. Task A has to function with task B. Task A could not do that alone effectively or very effectively, all right? So that's an essential interaction, and there are some tasks in the mission that have to be performed in conjunction with other tasks, all right? So we have essential interaction there. We do have a third case of interaction. It's where either an unforeseen event happens or circumstances. We call it, what do we call it? Conditional interaction. It's based upon the condition of the mission. And in this case, we do have an interaction, but it's a negative interaction, okay? It doesn't help us a bit. It really gets in the way, but it does interact. What we can do then, because we're good analysts, we can organize our thinking here and construct a task interaction matrix that you see here. And it does represent essential interaction and conditional interaction. The X actually happens to be, in this case, conditional interaction, and the dots are considered to be essential interaction for this particular type of mission. So we can organize our thinking here. We can list the interactions that are going on, and we can record them in our report. And again, okay, let me see that slide. Now, what we're going to do with this then is we're going to take the two notions of task interaction on the one hand and time compression on the other hand and put those together and give them some kind of a rating, all right? And this is a simple notion of how one might do that. Here we have three conditions that could occur in the mission. We have, reading from left to right, we have individual tasks being performed in a relaxed time condition, IRT. Then we have, perhaps, multiple tasks or multiple interactions that are being performed under relaxed time conditions. And finally, we have, obviously, the highest task loading portion of the mission, where we have multiple interactions going on under increased time conditions, increased time compression. All right. That receives the highest weight in our weighting scheme here. We notice that that's a pretty good discriminator then to help us understand what is the task loading in relationship to all the tasks that we have selected for our analysis. And some would be higher loading than others. Remember now we looked at task difficulty. Task difficulty was task loading plus processing complexity. Now we're going to look at processing complexity. How complex then is this task to process? Is it an easy task to do, or does it require a lot of complex processing? All right. Now from decision theory we know that a decision task is more complex from a processing standpoint than a non-decision task. And so we can look at this task set that we have identified from this perspective. We can say it is or is not a decision task, and if it is a decision task, what kind of decision task is it? And from the theoretical people, we know that there are likely two types of decision tasks that are going on in this particular portion of the mission. There's a type 1 decision task and a type 2 decision task. And we can discriminate the decision tasks from that standpoint. A type 1 happens to be the most complex. That's a decision task where over here, leave that up, Don. You're basically jumping into an unknown sea. You don't know what's going on. An unforeseen event has happened, and you have to, what the psychologists say, you have to restructure the schema. You have not a pre-planned action. You don't really understand what's going on, and the technical term is problem structuring. And there are a number of type 1 decisions in the air combat mission. There are things that you just don't know enough about, and you have to kind of wing it, okay? That's a type 1 decision, pretty complex, processing required, and it could represent a potential failure of the mission. If you have too many of those type 1 decisions, then you very quickly lose situation awareness. Then you would have a type 2 decision, and hopefully most of the mission is type 2 decisions because you've briefed it properly. I see Doug over there, right? We always used to brief our missions properly, right? So we were trying to eliminate as much as possible type 1 decisions, the unknown, okay? We try to understand the mission in sufficient detail so we can then process things easier. A type 2 decision is one where we know what the alternatives are, A, B, or C, and we just select the most optimum one at the time, okay? It still requires selection, so it's still pretty complex, but it's not as complex as this. All right. Now, Graham mentioned a good point. A real live example of a type 1 decision is wind shear. For years and years and years, airlines were crashing into the ground on approach or takeoff, and no one knew why. And finally, the FAA, with the help of Congress, funded a study, and they said that, okay, we've got a situation here where the pilots simply don't know what to do. The pilots were, in effect, experiencing a type 1 decision. They were never trained on wind shear, had no idea of what to do. So what they did then is they come up with a wind shear training program to try to move this thing out of the type 1 domain, which was extremely complicated to perform, to get it closer to the type 2. You're not there yet, by the way, because there are certain things that we still don't know enough about wind shear. For example, we don't know, there's no set procedure on wind shear recovery. There's some guidelines, but we still don't know how rapidly to pull up, at what rate, at what G onset, or those kinds of things, all right? But we're trying to move that out of the exclusive type 1 domain and get that closer into type 2 domain. Unfortunately, there's a lot of type 1 decisions left in the air combat area. How do we analyze the decision? We can use classic decision tree analysis. Okay, everybody familiar with that? I'm sure most people here have used a decision tree in one form or another, right? Yes? You can use classic decision tree analysis. You know, there's some criticism in using that, but it's a good way to represent what the decision might be. Here we have a very top-level decision here, okay, where you're trying to determine the attack plan and you have a very top-level decision tree constructed. This is our decision tree conventions that we could use, all right, in our decision analysis portion of this study. That's fairly well straightforward. That's, you know, that's decision analysis 101, which we all understand. This decision tree can become quite complex, and we need perhaps to get down to some additional level of complexity here. In this case, we have it's still a fairly top-level decision tree, but you notice that it is becoming more complex. There's a lot of decision nodes. a lot of decision opportunities. We notice that even some of the technologies that we've thrown into this decision tree require additional decision making. So it's a fairly complex environment. Specifically for our problem scenario that we saw in the video, this is our decision tree. And actually it's flowing, it's beginning here, and then it's completing there. And I just show this to help you orient your thinking in where we are in the mission. We want to center on this decision tree here. This is the specific decision tree that we're trying to deal with. Now, specifically what we're trying to do is, remember, we have already commenced the aspect maneuver, correct? We have already turned to the left. Remember that on the video? What are we trying to do? Well, as a Crack Tiger team, we have determined that what we're trying to do is we're trying to match our target aspect angle, and we're going to get into this in detail in a minute, but we're trying to match a target aspect angle with the thread dynamics. Because if we have a good match, then we can begin to understand the intercept geometry. All right, so that becomes a decision node. In order to do that, we need to select the right maneuvering package. Now let me ask you, gentlemen and ladies, if you felt, based upon what you saw in the video, that the right maneuvering package was selected.
20/20 hindsight, no.
No. Didn't look like it anyway, right? Okay, with some, obviously some, some humility, because we weren't there. But we're looking at it and we're saying, well, if he selected maneuver package A to perform that maneuver, perhaps that didn't look like it was optimal, okay? So that's all we're trying to get at. We're just trying to structure the decision and look at it in that level of detail, okay? Now what do we do with this? Let's say that this might be a cute exercise, but what do we do with this? There's two things we can do with this decision tree. We can ask ourselves, is it stable? Or is it unstable? Now what does that do? That helps us determine if it is in fact a type 1 decision or a type 2 decision. Now, clearly if you can't even begin to structure the decision, that's a type 1 decision. You agree with that? At least for the moment, you agree with that? If you can structure the decision, you don't agree? You do, okay. If you can structure the decision, all right, but it just falls apart at the least little wind blowing, it's probably a type 1 decision, okay? In this case, we say, this appears to be moderately stable. And so we have gone out on the limb a little bit and said, this is a type 2 decision, okay? You with me? And let's just assume that for the rest of the day, that we have agreed with that position, that it does appear to be moderately stable. It's not going to totally collapse when the least little thing comes about, and we can construct it, okay? And then it then fits into our type 2 decision category. Okay, now we're going to use that data. We agree with that for the moment anyway, that that's a type 2 decision, okay? Okay, this side here, right, we're going to then take that information that we have just collected with our decision analysis study here, and we're going to give these tasks weights depending on the type of decision or whether or not there's a decision involved in the first place. So we've got this little rating scheme here that we've cooked up, and it just came off our Macintosh, our laser printer, and we cooked this thing up and we said, hey, look, guys, it looks like a non-decision ought to be given a fairly low weight in processing complexity, and a type 2 decision ought to be weighted higher. And finally, a type 1 decision ought to be rated the highest because we think it's probably the hardest to process. So we come up with a rating scheme, okay? 1, 5, or 10, depending on what category this task falls into, okay? Okay, Graham said I should be over here, right? Specifically, we're dealing with, remember, 6.0 and 6.1 task. And how did that fall out in our analysis? Now, this is the final portion of this report that we're about to deliver to the Air Force. And we have, our position is that, okay, Mr. Air Force, you got a type 2 decision going on here because it's moderately stable. And we have assigned that a weight of 5. Okay, are you with me on this chart? You see under processing complexity, it has a moderately high task loading rating. We assign that a weight of 6. Combine those, and in this case, we just multiplied them together. 5 times 6 is 30. Our task difficulty rating on the far right-hand column is a 30. Okay, now, to check ourselves and to make sure that we can prove to the customer that we understand what's going on in that portion of the mission, we've also done the same thing for all the other tasks. Okay? So we don't want to look at this thing in total isolation. We want to prove that we can do this across that dimension. And we've looked at the other tasks. And as it turns out, 6.1 is a fairly difficult task. So we're not dealing with trivia here. We're dealing with a very difficult situation, and we can quantify that difficulty. Okay? That completes this sub-portion of the task difficulty analysis. Remember, it's a combination of task loading and processing complexity. We're going to do one little other sub-module here, combine those two, and finally get with a task criticality analysis. Any questions so far on this sub-module here? Yes, sir.
Well, the weightings seem to be fairly arbitrary. I mean, do you have a historical background to draw from to pick out these numbers, like 5, 10, 6?
The weighting is on purpose. We kept it very simple for this tutorial and for the other workshops. Okay, we've kept it very simple. Yeah, good point. It probably ought to be a little bit more. For example, 1 to 10 is not a very good scale. Okay, 1 to 9 or 1 to 7, right? You agree with that? Yeah, okay. Come up with a better scale, sure, yeah. We kept it simple for understanding. I don't want to get into the details of scaling notions and statistics and all of that stuff, all right? But we can use that, all right? And we can manipulate this data all kinds of different ways. But this, you see what I'm trying to do? I'm trying to keep it simple so you can get the basic ideas going here. Okay, and if you want to add to that, then absolutely. Yeah. Okay, we're going to do one more thing here because we decided, if you remember when we started this module, we decided that we don't want to deal just with difficult tasks, but we want to deal with tasks that were difficult but also fell in an important phase of the mission. And we thought that that represented a good notion of criticality. Okay? So one more thing, real quick. We got together with a bunch of subject matter experts, and we said, okay, Mr. Subject Matter Expert from Fighter Weapons School, we want to know where are the important areas of the mission. And this is the whole air combat mission that you see listed on the left, and we have various goals identified. We've given them scaling, weights, and so forth and so on. Fairly elaborate study, but for the sake of our purposes here, let's assume that we did that. We had a group that went out to the Fighter Weapons School. We got this data from the subject matter experts. They came back and said, okay, this is how it all fell out on the right-hand side. What we're going to do then is we're going to take that weight that you see on the right-hand side and plot that on the y-axis of an XY plot. On the x-axis, we're going to plot task difficulty, which we just finished. All right? Now, that's going to give us a notion of criticality, we think, but let's see how it works out. First of all, we're going to take this XY plot and we're going to decompose it into 4 cells. We're going to say that, okay, the upper right-hand cell is highly critical. Those are highly critical tasks because they're tasks that are very, very difficult to do, and they fall in a very important phase of the mission. Okay? You kind of agree with that notion? And conversely, tasks, we may have some tasks that are critical, they're not quite as difficult, but still fall in an important phase of the mission, and so forth and so on. And down here you see we have tasks that are least critical. So we take that notion and we see what kind of plot we get. And this is the plot, basically, of the whole mission. And we're looking specifically at our guy here. And our guy is right there, all right? That's the guy we're centering on, but we're looking at the whole mission in this particular case. And we're seeing where the plots fall. Fairly interesting distribution here of criticality. Now, what can we do with this? What do you think we ought to do with it? Well, we need to understand why. Something about what, well, why did it fall? Why did these tasks fall out here? And what we can do then is we can say, well, these tasks we know are all what? Type 1 decisions from our data. Okay? We can deal with those in a certain way in design. We know also that these tasks right here are all type 2 decisions from our data. And we can begin to deal with those in a specific way. And thirdly, we can see that this group of tasks, while are difficult, they are not decision tasks. Okay? And we can deal with those in a certain way. You see how we can kind of discriminate this thing here a little bit? Yeah. Okay, you begin to see how you can play with this. I haven't figured out all the ramifications here, but that's just one notion where you can look at this thing from, okay, this is a group A, and those tasks we're going to deal with in a certain way. And you might even give those group A tasks to a certain portion of your Tiger team and say, okay, Jerry, hey, work on those. Okay? What is going on there? And Jerry's going to come back and say, hey, boss, they're all type 1 decisions. They have to be allocated to the human. All right? There is no machine known to man that can process a type 1 decision. Good stuff, right? Okay, what does it do? It goes into the human decision-aiding box. We're going to try to help the human, but there is no way we can automate that out. Type 2 decisions then go into Joe's area, and Joe is given the job of figuring out what's going on here. And Joe comes back and said, boss, type 2 decisions, or this group B, are all type 2 decisions. And they're candidates for AI. Hey, good. All right. C are critical tasks, but they don't require any decision processing. Okay? So we're going to treat those with just normal software and hardware treatments. Okay? Now you may come back and say, or you may go back to your boss and say, boss, we got a bunch of type 2 decisions here, but we're not really all that good in AI, so let's bring in some AI experts, or let's get smart in AI. Okay? So you see where I'm leading here? You see the kind of the notions I'm trying to get at? Okay? Good design drivers we're starting to get to. This is the first major design driver. If you had to look at this package today, we're going to be looking at a number of design drivers. We think this is one of the major ones that is going to help you to drive a design in the direction that you think is going to achieve mission success. Okay? that essentially completes the critical task analysis or criticality analysis module.